Alright, here we're going to be learning about finding the area of composite figures. So we talked about finding the perimeter, which is the outside of the shape. Now we're going to be talking about finding the area, or the inside, of these shapes. Again, a composite figure is really just more than one simple shape put together. So you see a bunch of simple shapes on your formula sheet. Any two of those squeezed together makes a composite figure. The area is the inside of that shape, or the amount that it takes to cover a shape, or it's literally the number of little squares or square units that it takes to cover a shape. I'm going to use that word again. But it's actually the number of little squares that it takes to cover a shape. When you find a number, that's really what you're finding. You're finding how many little squares that can cover a shape. So we're going to split these shapes into simple figures. Again, those are all just shapes that you see on your formula sheet. We're going to find the area of each of those shapes separately, and then we add those together. Your formula sheet is going to be really helpful for right now. Actually, I'm going to pull up the formula sheet right now, just to show you a couple of these formulas. So we have the area of a rectangle, area of a square. Really, those are the same thing. S times S. I know you can't see it that clearly, but that's S times S. It's the exact same thing as just length times width. So most of the time, I'm just going to rely on length times width, regardless of whether it's a square or a rectangle. Area of a triangle. That's 1/2 the base. That's the bottom side times the height. That's going straight up and down. Area of a circle is pi r squared. So we square the radius and then multiply times pi. This is a parallelogram. We multiply the base side, again that's the bottom, times the height. It's kind of like a rectangle. It's just length times width, except the height is going straight up and down. It's not really down that slanted side. And this is a trapezoid. So that's 1/2 times the height. Again, that goes straight up and down, times B1 plus B2. That's the two bases added together. It doesn't really matter which one's which. It's just the top and the bottom added together in parentheses, so that we multiply that times 1/2 and then times the height to find the full area. So use this formula sheet a lot. I know I told you not to rely on the formula sheet so much for perimeter, but for area, directly rely on the formula sheet, find the area of each shape individually, and then put those pieces together. So let's think about how we can split up this first one. I definitely see, actually, this is pretty much already split up for us. I have a triangle there. Let's split it here. I have a rectangle there. And then another rectangle on the left side. So we really just want to find the area of each of those individually and then put them together. So for each rectangle, we're going to do length times width. So for the blue rectangle, that's 5 times 4, or 20. For the green one, this side, it's not 12, even though that is labeled as 12. 12 extends all the way across the bottom. So this part of it is 4. The whole thing's 12. That means this part has to be 8. So really we have a square there, even though it does not look like a square. That's 8 by 8. So we multiply 8 times 8 to find out that the area of the green rectangle or green square is 64. Right, then we just have that triangle left. So the area of a triangle is 1/2 base times height. So I'm going to use 1/2 of the base here is 8. That side is 8, so that side also has to be 8. That's the base of the triangle. So we could do 1/2 times the base of the triangle, which is 8, times the height of the triangle, which is 3, to find out that the area of the triangle is 12. And now we can just add those three numbers together. 20 plus 64 plus 12 tells us that the full area is 96 centimeters squared. These units are square units, whatever the original units are. It's just those units with a little exponent of 2 to show that it's actually the number of little squares that fit inside of the shape. That's actually what we're talking about. The number of tiny little squares that it takes to cover that whole shape is 96. All right, on number 2, I have a half circle at the top. I have a rectangle and a triangle. Alright, so it's pretty important that you just label the dimensions that you have. Let's start with the easy one first. Let's start with the rectangle. So I have 14 as, let's say that's the length. So again, area of a rectangle is length times width. So that's 14 times the width of that is 20. So that is 280 for that green rectangle. The blue triangle, I'm going to use 1/2 base times height. Remember, you're not using Pythagorean theorem here. Pythagorean theorem is to find the missing side of a right triangle. That's talking about the border of the shape. Here we're talking about the area. So we're using area of a triangle, which is 1/2 base times height. So the base of that triangle, I have to think about the entire length going across from there to there is 32. This part of it is 20. So 20 plus something to get us up to 32, that part has to be 12. So the base of this triangle is 12. The height of the triangle is really just this side in the rectangle, so that's 14. So we can do 1/2 times 12 times 14 to find out that the area of the triangle is 84. Alright, now I have that red half circle at the top. I'm going to redraw that circle just so I can see what that really looks like. I'm just going to redraw that circle with the 20 going all the way across there. That's important. The 20 is the diameter of that circle. Finding the area of a circle requires the radius. So I have to cut that in half. I can't use 20, I have to use 10. The radius of that circle is 10. So I'm going to do pi times 10 squared. That's exactly how I'm going to type it into my calculator. Although I'm going to change pi into 3.14. You can use the pi key also. I just know that the SOL uses 3.14, so that's what I'm going to use. And then we're going to do 10 squared. And that tells us that the full area of a circle that looks like that is 314. The area of this circle is 314. I do not have a full circle. I only have the top half of that. So we have to divide this by 2 to find out that the area of that half circle is really 157. Now I could put those 3 parts together. So there's a bunch of steps to finding that half circle. First off, you're given the diameter, so you can't even use that number to start with. You have to cut that in half to find the radius. That's the number we need for the full area. But then we don't use that number because we don't have a full circle. We only have half of a circle, so we divide that by 2. Now we can add those up and find out that the area is 521 millimeters squared. Alright, so on number 3, Mr. E is making a large paper E to hang on his office door. Each piece of construction paper is about 600 square centimeters. So each piece is 600 square centimeters. How many pieces of construction paper will we need to design the E below? So first off, we need to figure out how big this thing is. And then we're thinking about how many of these it will take to cover the whole thing. So let's split this shape up. I see a rectangle here. I'm just going to cut it off there, there, and there. And then we're going to multiply length times width for each of these. They are all rectangles. I have 4 rectangles, each with the length and the width, that I can multiply to find the area. So 50 times 14 tells us that this rectangle has an area of 700. This line being marked there, 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 that's saying that all of those are congruent. It's saying that each of those, if this is marked with that line and it's labeled as 14, that means this is also 14. So this rectangle is 25 times 14, or 350. The bottom one is the same as the top, so that is also 700. And then the one on the left side is 70 times 12, which is 840. So I'm going to put those 4 together and find out that the full area is 2,590. That's the area. That's not my final answer, though. I want to figure out how many pieces of construction paper it takes to cover this. So I'm thinking about how many of these it will take to cover that amount of area. So I'm going to divide 2,590 by 600 and find out that it would take about 4.32 pieces to cover the entire thing. I don't think it really makes sense to talk about 0.32 pieces of a construction paper, so I think we really need the fifth piece to cover this whole thing. I think we need 5 pieces of construction paper to cover the whole thing. Alright, finding the area again, we're going to split this into a half circle on the bottom and a rectangle on top. Area of a rectangle is length times width. That is 30 times 12, or 360. Area of a circle is pi r squared. So I really want to think, is 15 the radius or the diameter there? I'm going to redraw that circle just so I can see it clearly. 15 is going from the edge of the circle. This dashed line is going across the middle. 15 goes to the middle of that circle. So 15 is the radius. That's the number I'm going to plug into this equation. Pi times 15 squared. I'm going to show what that looks like in the calculator, which I already have it up there pretty much. Pi times, instead of 10, I'm going to change that to 15. So the area of that circle would be 706.5. The area of this whole circle would be 706.5. I only have the bottom half of that, so I really don't want that whole thing. I'm going to divide this whole number by 2. Well, that's actually the same thing, but that's not how I want to show you. I'm going to divide that whole thing by 2 and find out that the area of that half circle is 353.25. Now I could put those two pieces together to find out that it is 713.25 meters squared altogether. Example 5 says you want to put fertilizer down in your backyard. Each bag of fertilizer will cover 50 square meters. We want to know how many whole bags of fertilizer. So that means we're rounding up to the nearest whole bag. We need to cover the entire thing, so we need that amount and a little bit more to make sure that we have enough. How many whole bags of fertilizer will we need to buy? So we have to figure out the whole area, divide it by how much each one can cover, and that'll tell us the exact number of bags, and we'll round that up to the nearest whole number. So first off, I gotta split this out. I got a rectangle there, and I have another rectangle here. So the length and the width of the blue one, 20 is labeling, let's say that's the length. 60 goes all the way across on the top, so this isn't 60. I know that this part is 20, because that's 20. And if the whole thing is 60 going all the way across, this part has to be 40, because 40 plus 20 would add up to that 60. So I can multiply those two, 20 times 40, to find out that we have an area of 800 in that big rectangle. The red one's directly labeled for us. That is 20, that is 4, that is my length and my width, so 4 times 20 is 80, so 880 is the total area. I want to figure out how many of these bags I really need, so I'm going to divide that by 50. That tells me that we need 17.6 bags to cover it exactly. So 17 wouldn't be enough. We really need the 18th bag to cover the entire thing. Alright, the last one is pretty involved. Julia's looking to install a new pool in her backyard. She wants to build a pool with the largest square footage. So we just want the biggest area here. Which pool should she choose? Alright, that first one, which is actually a hexagon, is actually split up for us into a trapezoid here, another identical trapezoid on the bottom, and then a rectangle in the middle. Alright, so the area of a trapezoid. It's 1/2 times the height times b1 plus b2. So the height of the trapezoid is always going straight up and down here. That is that 5.7. So it's 1/2 times 5.7 times b1 plus b2. That's the top and the bottom. b1, b2. That's 19.4 plus 8. So 1/2 times 5.7 times 19.4 plus 8 tells me that that trapezoid has an area of 78.09. We have the exact same trapezoid on the bottom, so I'm going to label that one too as 78.09. Now we just need the rectangle. There we're going to multiply length times width. Length times width there is 8 by 19.4. So we're going to multiply those two together and find out that that has an area of 155.2. So the total area of that shape is 311.38. Right, on the second one, I have a square here. So that's going to be length times width. And then I have a half circle. So that is going to be pi r squared. I guess I should write the full thing. Area equals pi r squared. And area equals length times width. So for the rectangle, that is going to be 22 times 22, or 484. Alright, now we got to think about this red half circle. So I'm going to draw that whole circle just so I can imagine what that really looks like and decide whether that 22 is the diameter of the radius. That is going all the way across. That dashed line goes all the way across our circle. So 22 is the diameter of that circle. So I really can't use that for the radius. I have to cut that in half. I'm going to use pi times 11 squared. Divided 22 by 2 to find out the radius is 11. And then we can multiply that together. Actually, let me show that. .14 times 11 squared. That's the full area of that circle. That's if I had that entire circle. I don't. I only have the left half. So we're going to take that whole number and divide it by 2. Find out that the area of that half circle is 189.97. So the full area of that shape is much bigger. That's 673.97. So far pool number 2 is much bigger. So far that one's winning. Now we have to find the area of that last one to compare it. So here on top, we could split this up, but actually we really just have a parallelogram on top. You can see that on your formula sheet. That looks exactly like this one that I've scribbled over. That looks like that one. It's just like a slanted rectangle where we are going to use the base times the height. So the base there is 18, the height is 12. So we're going to multiply those together, find out that that has an area of 216. And then on the bottom, I'm going to highlight this in green. We have this green triangle. We're going to use 1/2 base times height. Or 1/2 of 18 times 11 to find out that that has an area of 99. So that has a full area of 315, which is not quite enough, so pool 2 is going to win there, and that one has to be the biggest.